Okay, after loading this data, we notice that the education is not partitioned out as categorical variables as dummy coded, correct? And the same for grade. Years 1 and 2 are fine. We need to adjust that if you haven't already. Age, let's see here. Let's correct this. Let's make that ordinal just to let us know. And then gender is treated as a string, so we got to change that as well, right? And then we have our salary variable. We can do it in Excel before we get the data into SPSS, or we can create new variables. And so I'll demonstrate with you that we haven't done this in class. We'll compute, and the way to do that is to compute into a different variable. So if we'll recode into a different, so recode, name, edu underscore 1, old value, right? If 1, 1, if 2, 0, if 3, 0, if 4, 0. Okay, and so we change like that, and click OK. And what this created was the variable that we did in Excel. So we come over here and look. Here's our, turn up the decimal. Like so, right? So we have grade 1, and we've got our binaries. Or education, sorry. Education, right? And then we would do the same going out. So I'm going to pause the video now and do this quickly, and then I'll recommit. One thing to note when changing these out, you have to go back, right? So for this value 1, it now becomes the 0 change, and then 2 becomes the 1. Just want to make sure you understand that change. And then we can leave the rest and say continue. Okay. And to check it, we can see now if we look at education, if it's a 2, it's turned on. If it's not, then it's off. So now I'll pause it. So that's completed. And we can look here where we've got our ordinal variables coded out by education. As a reminder, when we have values that are, uh, you're always 1 minus, right? So if we have a total of 5 categoricals in this situation, we should have 4 columns. That fifth category is the referent. In a case of like gender here, which we can't really process anything here analytically, we need to code this out as well. We would, uh, since we have 2, we'll have 1 column. We have 2 variables, since we'll have 1 column. And the way we do that, let's recode that. Let's go to gender. So if it says male, we want 1, and this picks up, and then female, 0. So it's got our string text, okay? And click continue, change, continue, okay. So now we've converted, right, based off of string text. And that's the way you do that. So it's a little easier, I would say, in doing it. But it demonstrated in Excel, you see how they do it with if statements, but within SPSS, we just computed the variable, okay? All right, so let's turn off those decimals like so. And there we go. So we've got our gender here. If you wanted to do, you could do this, right? We could come over here to the values, just to help you know, I guess. 1, male, 0, female. So that's a way to label it. Okay, this is a relatively, let's see our data set here, and we got a decent amount. We're at 208. So it's a little bit on the lighter side to process some machine learning, what we're going to do. Okay, I can tell we've got some missing data right here. Looks like on observation 44 for their education. So, um, anyways, as discussed in class, the way that we analyze, right? So we look at regression, linear, and we want to predict salary dependent. And then let's do gender. And then years are continuous. We'll hold off on age for now. Statistics. We'll look at the collinearity. The case-wise lets us to see potential influencers. Okay. Urban Watson is a check for multi-collinearity. We'll look at the collinearity here as well. Okay, we want to look for independence in the predictors. Continue. And a good practice is to observe, look at the predicted onto the residuals. Okay. Okay. And here we go. This looks a little bit different than what we did in class. We're missing the variable. Hold on. It looks like it dropped. Education 3. Where is Education 3? We've got Education 3. Looks like when we did our data conversion, several of our values did not get put in. Let's see if this will fix it. Typically, I don't like doing this. It looked like whenever we incorporated it, I've had it. Yeah, there's something going on squirrely here because I thought we could fix it like that, but now that I'm looking, we've got, I, we would need, it's not necessarily, this is going to be all of our graduates. Let's do that. That'll have, this has got to be the graduates which are not being picked up. This should fix it. This is category 5, right? Okay. So if I come up here and select this, this should fix our model. Sometimes when things like this happen, it happens, and it's a good teaching point as well. Even though we converted our variables into categorical, it didn't know how to handle the graduate students since they had no values. So that's what's going on. Sort ascending. We should get our model like we would like to see it. Let's go back here. Okay. And there we go. This is an accurate model. Okay. So now we're explaining the values that we covered in class. Know that you you could get some blank values like that, and the again the reason being for that to occur, when we created education 1, it didn't find a 0 when, like, it didn't populate the 0 like we would have hoped, based on the logic of the argument. I could have put another one in there. 5. So whenever I didn't put 5 in there, if I go back here, folks, this is what happened. I did 4, right? So if I go back over here to, we could have created dummy variables like that too. But if we recode in different variables right here, this is a really actually good teaching moment. Okay, old and new values. Right here, when I put in 1, 2, 3, and 4, I didn't put a 5 in. So since I didn't put a 5 in to create the 0, it left it kind of blank like that. If I would have put a 5 in and said 0, that would have populated it. Okay, the alternative is if we go over here to transform, create dummy variables, and if we want to create a dummy variable, okay, we could do that like this as well, and name it. Okay, if we come over here, here's the dummy variable. So it's showing it turned on and turned off. We would only need one of those. Again, this is another way, but no, when you create the dummy variable, it's going to give you the 1 and the 0. So either way works. Just know when you do a dummy, you'll need to go back. I mean, you need to delete one of these columns. Okay. I'm going to delete both of these. So good stuff to learn while navigating through this. Okay. Moving along. We got a regression and we've interpreted it. Okay. So we've looked at model fit. Let me go back. Okay. We look at the higher level. What's our summary show? Well, our Durbin Watson is less than 2, so that's good. The standard error of the estimate, I'll put that in perspective for you here in a little bit. We're looking at the R square, and we're explaining roughly 64% of the variance. And our adjusted R is not lagging too far behind that. So that's a good sign too. Okay. So this gives us a feel. As we drop into the ANOVA, this tells us we get some significant predictors, which shouldn't surprise us too much because we're seeing some decent fit up here. If you look at my annotated Excel sheet, you will be able to see how these values are calculated based off the summation of the predicted Y, minus the average, and so forth. Um, Again, degrees of freedom are the amount of predictors, not the ones that we can't see, i.e. the referent, right? So if you count here, 1, 2, 3, 4, 5, 6, 7, we've got 7 predictors. Okay, so as we look at these different categories, or coefficients, right? These are based on all 207, okay? And so the coefficients are on a complete sample. And scrolling down, we can see now that we have all our data is complete, we're filled for, if we don't, for the education 5, they're all zeros, right? So now it's evidence. Okay, so looking here at the 207, it's always 1 minus the total sample. So we have 208, 1 minus, that's 207 for degrees of freedom. Our 7 degrees of freedom has to do with 7 predictors. What you're not seeing there has to do with the referent variable. So if you count our IVs there, there's 7 of them, okay? And so that's where that's coming from. And then the residual, it's just the difference of the 1 degree of freedom of the total minus the predictors. It gets us 200. So that's what we're looking at on the ANOVA component. Okay. Let's kind of point here and let you look. We got 7. Again, the reference aren't included. That'd be 9. We don't show those because they're zeros. About it, but just we're not going to get into it too much. The VIFs look good if we look at that. They're all within 1 in our tolerance. I'm bringing up tolerance. We're looking at more of the 1 values on our VIF, okay? And that looks good too. The residuals here, or those are potential, those values will pull us a little bit with influence. We would probably consider removing them, but we need justification. Obviously, they're pretty influential based on looking at standard residual of anywhere from 4 to -5. So that does play a factor. We won't remove them because we're not diving deeper into why they're occurring. The histogram level looks pretty good. No concerns there. I would say there's a little bit of concern, even though it follows the line, it's off the line, right? So there is a little bit of concern there. It does follow a straighter line, but there is concern because it doesn't get back on a fitted line on a standardized residuals. Um, if this was in a real scenario, I would be uh, much more concerned on the integrity of the data and making our inferences. But for purposes of class, it's okay. Patterns, right, for how the predicted standardized residuals relative, and we look at standard deviation. We've got a couple of outliers. We can see there in the bottom quadrant, but for most of them, the pattern's pretty tight, right on this, right on the 0, right? So right in the middle. We got some of the 2, but popping out on the 5, that we would that gives us a little concern. So that don't mind this dummy variable. This is when we created it, just kind of showing you from the transform. That's all that is. So nothing too major at that point. when we create samples, right? So when we want to split the data file, and this is the way that we partition it to create our training and validation set. And so if we go over here and do the sample and we set it at 80% like so, it's going to randomly choose values. This is kind of the beginning phase of cross-validating. Here's the thing, even though we got a filter value, we got to create another category. It doesn't work too well out of filter, and what we're going to do is copy and paste that and move it over, and then we'll relabel it and we'll add some data labels, and that will be our kind of our how we choose our sample. But don't do it off the filter, right? Like I said, the easiest thing is just to copy and paste the values. Go to the very top row, Control C, we'll paste over. And this turns all the values back on by selecting all, okay? So you can see that. But we want to turn them all back on before we, so you don't, here's my thing, you don't want to copy and paste just with the filter one, the randomize. You need to turn everything back on or else you're going to miss values, okay? So insert a column and change the name of it. Let's call this sample. Okay, and now go to the very top one. And then from here, Shift Control down, kind of like in Excel that capture everything. We're at 208 observations. Shift Control down, Control C. I'm copying, and then Control V. That will paste them, and we can kind of look here, make sure that we're getting all those back. You got to pull it off the filter. Is my point. You can't use what we're getting ready to do. You can't leave it in the filter. You need to create a separate variable. Okay, and we look good. We don't need the filter anymore, so after we've done that, we can delete it. Clear. And let's go over here. Scroll up, and here's our sample. And what I want to do is turn off those decimals, and let's code this out. Okay, so we're going to change the value. 1, 80% training. 0, 20% validation holdout. This isn't a test set, this is a holdout. Typically what we would do with this, after we complete our validation assessment, we would do some type of maybe grid optimization. We do some hyperparameter tuning. We would adjust those parameters to fine tune it, and then we would use those inputs and assess how it is on a test set. Okay, which would be typically we do an 80% training, 10% on the validation, and 10 on the test. The point being, you need a rather large data set. This is pretty small to be doing this, but it's for the principle. So if we come over here, you can see we've got, like so, if we want to change it to the values, right? So we can, when I labeled it on the back side, this is what's going on. So this is male, okay, there's female. If I turn this back, we see the values. So that's a kind of a useful to show your value labels or not, okay? Okay. So now, and we can make this, it's nominal. I'm gonna, stop the video here and do a part two and continue this for time purposes.